Chapter 6.2 Homework Solutions. Number 7. It lets us know this is a parallelogram, and what we need to know, the marked angles are consecutive angles, and by theorem 6.4 the angles are supplementary. So to set this up, we know those two angles must equal 180. So we got the one is 53 degrees and the other is x degrees, and they have a sum of 180 because they're supplementary. So we're going to subtract 53 on each side, which leaves us with x equals 127. So the answer is x equals 127. Number 8. A parallelogram has two consecutive angles. The two consecutive angles over here are 113 and x. So we know consecutive angles of a parallelogram must be supplementary, which means they have a sum of 180. So we can write this equation as 113 plus x equals 180. Okay, subtract 113 from each side so we can get the variable by itself, and we get x is equal to 67. Number 9. Same concept. We know this is a parallelogram, and x degrees and 80 degrees are consecutive angles. Or if you will remember, we could talk about these two lines being parallel. So those are same side interior angles. So they must be supplementary, have a sum of 180. So we can set up x plus 80 equals 180. Well, you subtract 80 from each side and you simply get x equals 100. Going on to number 10. Same concept. It's a parallelogram, so we know consecutive angles, the two angles side by side, must be supplementary, which means have a sum of 180. So again, we can say x plus 62 is equal to 180. Subtract 62 on each side, and we simply get x equals 118. Okay, number 11, developing proofs. Complete this two-column proof of theorem 6.6. Given ABCD is a parallelogram, prove that AC and BD bisect each other right at point E. Okay, so we're trying to prove that AC and BD bisect each other. So step 1 is always for us the given. Well, what was given? Number 1, ABCD is a parallelogram, so that's given. The next step says AB and DC, okay, AB and CD are parallel. Well, that's true. That's part of the definition of a parallelogram. Okay, so that's easy enough. Now what it tells us is angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. Okay, well, if we remember from parallel lines, okay, we have a Z formed here. Remember, AB is parallel to CD. We call BD the transversal, and if we remember, alternate interior angles of two parallel lines, of a transversal of two parallel lines, are congruent. So we could say 2 and 3 are congruent, and then if you look at transversal AC, okay, we can conclude that angle 1 must be congruent to angle 4. Again, alternate interior angles of transversal of parallel lines are congruent. So the reason then on number 3 part B is this. Alright, if lines are parallel, which we already proved, alternate interior angles of parallel lines are congruent. Okay, the next part says AB is AB is congruent to CD. Okay, well, that's the proof is opposite sides of parallelograms are congruent. Okay, so now what do we have here? We have triangle ABE. Highlight that for us. Triangle ABE, okay, must be congruent to triangle CDE. And we prove that through angle side angle. Going to step 6. Alright, AE is congruent to CE, so let's erase all that stuff. So AE must be congruent to CE, and BE must be congruent to ED. And again, remember, we just proved the two small triangles right here were congruent to each other. Okay, and we can prove that because corresponding parts of congruent triangles are congruent. Okay, and then part 7, AC and BD bisect each other at E, because that's the definition of a bisector. Easy enough. Okay, going on, number 12. We've got an equation here, we've got a parallelogram. What do we remember about parallelograms? Opposite angles must be congruent. So we can set these two equal to each other. So we can say 6A plus 10 equals 130. Minus 10 from each side, subtract 10 from each side, we get 6A equals 120. Divide each side by 6 to get A by itself, and we get A equals 20. Number 13. Again, opposite angles of a parallelogram is congruent. Opposite angles would be this one and this one. So we can say 2A plus 30 equals 4A minus 4. First thing I always like to do is I like to get the variables on the same side of the equation, preferably positive if I can do it. So I'm going to subtract 2A on each side. So I'm going to rewrite the equation now. After the subtraction is 30 equals 4A minus 2A is 2A minus 4. Now the next step algebraically is to get the variable by itself, so we're going to add 4 to each side. Okay, so we're going to get 34 equals 2A. Now we got to get the variable by itself completely, so we're going to divide each side by 2. So A is going to equal 17. Okay, going on, 14. we've got a problem here. Again, we know two parallel sides intersecting another set of parallel sides is going to make a parallelogram. So we know opposite angles of parallelograms are congruent. So we can say 3a plus 50 is equal to 104. Okay. And then all we have to do now is solve for a. Subtract 50, get a by itself. Subtract 50 to each side. So we're going to get 3a equals 54. Divide each side by 3. We're going to get a equals 18. Okay, number 15. Find the value of a and then find each side. Okay. Well, luckily for us, there's only one equation, or one variable, I should say. And what do we remember about parallelograms? We know opposite sides are congruent. Opposite sides are congruent. Okay? So we can set them equal to each other. Well, looking at it, BC equal an AD, so we can say BC, segment BC or side BC is congruent to side AD, and we can replace the variable. So BC is A minus 3.5 equal to, well, AD is 18.5. Subtract, or sorry, add 3.5 to each side, and we get A equal to 22. Okay, well, it also asks for the sides. So AD was already given to us, so AD is equal to BC, which is equal to 18.5. So there's those two sides. And now, up top, we can say BA is equal to CD. CD has an equation of A plus 1.6. Well, we have the A value. We'll just plug it in. So CD equals 22 plus 1.6. So CD must equal 23.6. So I can say CD is equal to BA, which is equal to 23.6. So we have all the information we need. First thing we did was we solved for A, which is 22. We came up with the top and the bottom. AD equals BC, which equals 18.5. And then the sides. CD equals BA, which equals 23.6. Okay, going to number 16. Same concept. We got to solve for the variable and then find the equation for all the angles, or find the value for all the angles. Well, we can do this a few different ways. What do we remember? Well, opposite angles are congruent, or consecutive angles sum to 180. So I'm going to go angle G equals angle K. So angle G is 20A plus 30. Angle K is 17A plus 48. I'm going to subtract 17A. I'm going to get all the variables positive to one side of the equation. So rewriting this, I have 3A plus 30 equals 48. Subtract 30 from each side, getting the variable A by itself eventually. We're going to come up with 3A is equal to, well, 48 minus 30 is 18. Divide each side by 3 to get A by itself. A is going to be equal to 6. Well, that's only one part of the equation. Okay. So let's solve for angle G. Angle G is equal to 20A plus 30. Well, let's plug in what A is. So 20 times 6 plus 30, which would be 120 plus 30. So angle G will equal 150. Okay. So over here we can say, well, angle G was equal to angle K is equal to 150. Alright, that leaves for angle H. Well, we know angle H and angle G are consecutive angles of a parallelogram, so they're supplementary, so their sum must be 180. We know angle G was 150. Okay, you can subtract 150 to each side. You can say angle H is 30. Okay, so you can say angle H is equal to angle J, which is equal to 30. The other way, and probably easier way to actually solve for angle H, is angle H, you can see on the left hand side, is equal to 5A, which is equal to 5, and we found out A was 6, so 5 times 6, which is equal to 30. But it's nice to know we can check it either way. But our solution's right here. A has a value of 6, angle G and angle K have a value of 150, and angle H and angle J have a value of 30. Number 17. A pantograph is an expandable device shown at the right. It is used in television industry for positioning lights and other things like that. In the photo, points D, E, F, and G are vertices of the parallelogram D, E, F, and G. Okay? That parallelogram is one of many parallelograms that change shape as this pantograph extends and retracts. Okay, so the question asks this. Number one, if DE, right here, is 2.5, so let's redraw this so we can see it. Okay, so we've got a parallelogram that has values of vertices of D, E, F, and G. Okay, so the problem tells us if DE, the distance from here to here, is 2.5, what is FG? Well, we know opposite sides of a parallelogram are congruent. So for part A, we can say FG has to equal 2.5. Part B says if the measure of angle E is 129, what is the measure of angle G? Well, the measure of angle G is an opposite angle of angle E, which is a parallelogram, so it has to have the same answer, so it's 129 degrees. Part C asks the question, what happens to the measure of angle D? Okay, what happens to the measure of angle D as E increases or decreases? Well, since the measure of angle D and the measure of angle E of the parallelogram have to always equal 180, when the measure of angle E goes up closer to 180, D must go down. So when the measure of angle E, when it gets smaller, they still have to sum to be 180, so the measure of angle D has to go up. Okay, number 18, prove theorem 6.4. Given ABCD is a parallelogram, prove A is supplementary to B and A is supplementary to D. Okay, first thing we're going to do, first step, let's think about this, is going to be AB, segment AB has got to be parallel to CD, and BC is going to be parallel to AD. Okay, that's just the definition of a parallelogram. Step 2 for us. Angle A has got to be supplementary to angle B, and angle A has got to be supplementary to angle D, because if we know two parallel lines, which we've already proven, which we already said, AB is parallel to CD, and AD, those are triangles in case you can't tell, is parallel to BC, we know they must be supplementary because same side interior angles, okay, of parallel lines are supplementary. So we're able to easily prove it. Okay, next one. Okay, 21. Okay, 21. Find the measures of the numbered angles for each parallelogram. So for 21, we've got to find the angle of 1, we've got to find the measure of angle 2, and we've got to find the measure of angle 3. Okay, well, the easiest one to see is angle 3 has to be equal to its opposite side, yes, if it's a parallelogram. So angle 3 should easily be deduced as 110. Okay, now the measure of angle 1, look at the diagram. We know, right now, we know that line and that line are parallel, and we know this line, I'm going to color in purple, is a transversal. So by alternating interior angles of two parallel lines, we can deduce angle 1 must be congruent to 38 degrees. So pretty easily we figured out 1. It was 110. Sorry, it was 38. And we figured out number 3. It was 110. Okay, so number 2. Okay, well, that could be a little confusing, but really we have a triangle already drawn. There's angle 1 that we're trying to find out. That is 110 degrees, and that is 38 degrees. So we know the measure of all three sides of a triangle, so the measure of angle 1 plus 110 plus 38 must equal 180. Again, the sum of the triangles of some of the angles of a triangle must be 180. So the measure of angle 1 plus 148 equals 180. Subtract 148 at each side, so we get the measure of angle 1 equals 32. Sorry, angle 2. Number 21. We have to find the measure of all three angles, angles 1, 2, and 3 in this parallelogram. Okay, looking at the diagram, just by inspection, the easiest one we can see is angle 3 must be equal to 110. Okay, just by inspection, we know opposite angles of a parallelogram must be equal. So the measure of angle 3 must be 110 degrees. Okay, if this is a parallelogram, we know opposite sides are parallel. That's the next thing we can really see. And we know right now any line that intersects two parallel lines has some unique characteristics and factors we've already proven. And one of the neat things we proved were alternate interior angles, okay, were congruent. So knowing the top and bottom are parallel, knowing the diagonal intersects them as a transversal, we know the measure of angle 1 has to be equal to 38 because alternate interior angles, okay, alternate interior angles of parallel lines. So we're able to figure out angle 1 is 38 degrees. Well, angle 2 is a little bit tougher if you think of it as in terms of a parallelogram. But if you rewrite or redraw the diagram you have, you notice angle 2 is part of a triangle that we already know the two parts to. We know the top angle is 38 degrees and we know the bottom right angle is 110. So our rules, if we remember, the measure or the sum of all angles of a triangle is equals 180. So we can say the measure of angle 2 plus 38 plus 110, the two known angles, has to have a sum of 180. So we can say the measure of angle 2 plus 148 equals 180. Subtracting 148 each side, we know the measure of angle 2 must be 32. So we were able to, just by inspection and going back and using our rules of parallelograms and using our rules of triangles and transversals and alternate interior angles, we're able to prove angle 1 is 38 degrees, angle 2 is 32 degrees, and angle 3 is 110 degrees. Number 22, same concept. Let's, by inspection, what do we know to be true about parallelograms? We know opposite sides are parallel. We know opposite sides are parallel. So we can say this diagonal is a transversal. With that being known, and opposite sides are parallel, and treating the diagonal as a transversal, we know alternating interior angles must be congruent. So we can say angle 28 is equal to angle 2, just by inspection, didn't have to do any math. So angle 2 is 28 degrees. Okay, so angle 3, by alternate interior angles, must be congruent to 81. So again, just by inspection, angle 3 must be 81 degrees. So there's a few different ways we could do this, but let's just go back to the easiest one, and let's go make a triangle. I'm going to highlight it here for us. So there's our brand new triangle. The sum of the three sides, we can say over here, 180. The sum of the three sides has to equal the measure of angle 1 plus 81 plus the measure of angle 2, which we already have. So it equals measure of angle 1 plus 81, and the measure of angle 2 was 28 degrees. So it's going to equal the measure of angle 1 plus 109. It's still 180. Subtract 109 to each side, you're going to get 71 degrees equals the measure of angle 1. So angle 1 is 71 degrees, angle 2 is 28 degrees, and angle 3 is 81 degrees. Last home, number 23. We have to find the angles measures of 1, 2, and 3. So this one may look difficult at first, but by inspection we can look and see angle 1 and 85 degrees create a linear pair, two angles that form a line. So they, by rule, must be supplementary. So we can say the measure of angle 1 plus 85 must be supplementary, so it must equal 180. Subtract 85 each side, we get measure of angle 1 equals 95. Okay. Next step, let's look at the triangle that we just created, or that we just saw for angle 1. So if we're looking at the little small triangle right here, we know the sum of all three angles must be 180. So we know the measure of angle 2 plus the measure of angle 1 plus 48 must equal 180. Well, the measure of angle 2 we don't know yet. Angle 1 was 95, we just solved for, and 48 was given, equals 180. So the measure of angle 2 plus, do your math, 143 equals 180. Divide each side, or subtract each side by 143, so you get the measure of angle 2 equals 37 degrees. So we got the measure of angle 2. If this diagram is a parallelogram, which it's given, we know opposite sides are parallel. And we know any transversal that intersects two parallel lines creates alternate interior angles which are congruent. So angle 2 must be congruent to angle 3. We already solved what measure of angle 2 was. So we can say the measure of angle 3 is congruent to the measure of angle 2. So we say the measure of angle 3 by alternate interior angles is 37 degrees.